All right, hello and welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. This is section 3.3b. We're going to look at annuities, loans, and bonds, part 2. In our previous video, we looked at an increasing annuity, where we are investing money monthly, putting it into the account. In this video, we're going to be talking about money coming out of an account. So you'll notice that the formula is slightly different. PV equals the payment times 1 minus 1 plus r over n to the negative nt, all divided by r over n. As in the previous video, for this course, I'm not needing you to do crunch the formula, substitute the values in, and then do all the algebra, the arithmetic without using the app. I'm very happy if you can use the TVM solver for this app. Okay, so let's look at some examples here. Example number 1, you plan to withdraw $50 from an account earning 2% interest compounded monthly. You want the account to last for 5 years. How much must be in the account to begin with? To know how much needs to be in the account to begin with, that's the PV that we're going to solve for. Okay. Since I want the account to last for 5 years, that seems to indicate at the end of the 5 years there's no money left. So our future value will be 0. Also notice that our 2% interest is compounded monthly. Our withdrawals of $50, it doesn't indicate, but we're going to plan on that being monthly. Therefore, our PY and our CY should both be 12. Also notice that the payment this time is negative. The payment's negative because I'm withdrawing the $50. In our previous video, it would have been positive because we were depositing $50. Withdrawing the $50, the payment will be negative. We want our money to last monthly for 5 years. That's going to be 60 months. So to calculate the present value, alpha solve, we need to begin with $2,852.62. Okay. Example 2. You think about retirement. How much money do I need to put into an account earning, in this case, 6.2% interest? If I'm going to take money out, how much money does my account need to be worth when I retire? So notice I'm hoping to retire at age 65. I'm currently making deposits into an account that's earning 6.2% interest. And I feel confident that the account will continue to earn that 6.2% interest. If I plan on taking withdrawals of $5,000 a month, how much my account need to be worth if I want to live to age 90? The implication is at the age 90, I need my future value, the amount then to be $0. Okay, so what would I need my account to be worth? Now, 90 minus 65 is 25, so I need this account to last me 25 years, which is 300 months. So the present value of my account, alpha solve, will need to be 761,519.39. I would need $761,000. If I want to think back to my previous video when I say, if I'm 25, and I'm going to be putting money into this account monthly for 40 years, how much do I have to invest monthly to get this to be worth the $761,519? All I would need to do is move that $761,519 down to my future value, but I'm going to remember that it would be negative. And then if I'm starting with $0 at the age of 25, what would my payments need to be? If I make payments of $362.12 into that account for 40 years, I'll have that $750,000 and be able to withdraw that out. More than this question asked for, but a little bit of extra thought is always good when it comes to investing. Suppose in example 3, I currently have $300,000 in an account that's earning an annual rate of 5%. And that interest is compounded monthly. And notice I'm going to take $5,000 withdrawals annually. So since my interest is paid annually and my withdrawals are annually, those PY and CY are both 1. So let's go back up and say, how long is this? The question is, how long will it take for that investment of $300,000 where I'm withdrawing $5,000 a year? How long will that take to get down to $200,000 a year, or $200,000 in value? How long? Alpha solve. That will take 14.2 months. Years, I'm sorry. We're talking years. So many problems I've done recently are months. That's going to take approximately 14 years to drop down that $100,000. Okay. Let's look at some loans, payments. If I've got to pay some things back, right? I want a new car. The new car I want to buy is going to cost me $25,000. Now, let me be clear. The cost of the vehicle is not $25,000. I need to finance $25,000. The loan will be $25,000. So there may have been the cost of the car, and then the cost might be reduced by any trade-in or down payment I make. Then it might get added back. It might increase again as we add in tax, title, license, and all that sort of thing. The financing of the loan is $25,000. If I finance that car for 3 years at 6% interest, what would be my payment? Okay, so 3 years, 12 months per year, 36 months, 6% interest. The present value of the loan is $25,000. And the future value of the loan will be paid off. That's 0. My payments are made monthly and my interest is compounded monthly. What will my payments be? Alpha solve. I would need to make monthly payments of $760.55. Unfortunately, I can't afford that. So I know I'm going to pay less interest if I finance this for a shorter amount of time, but I can't afford that. So what if I go to 4 years? Well, if I go to 4 years, that's going to be 48 months. My payment now, alpha solve my payment would drop to $587.13. If I go to 5 years or 6 years, I know my payment's going to drop. The amount of interest I pay will increase, but notice N is 60 for 5 years. Alpha solve my payment would be $483.32. And if I go to 6 years, that would be 72 months. My payment would be $414.32. So you'll notice that the payment amount is dropping, but it's significantly less for each additional year. From 3 years to 4 years, my payment dropped by about $170. From 4 years to 5 years, it only dropped about $100 a month, and then only about $70 a month if I went 6 years. If I keep going too high, I'm just paying more and more in interest to do that. But speaking of that, we do know that the shorter the life of the loan, the less interest you will pay. The longer the life of the loan, the more interest you will pay. So a question would be, how much more will you pay for 6 years as opposed to 3 years? To do that, what I'm going to do is I'm going to say I paid $414.32 for 6 years. That would be 72 months. If I finance the car for 3 years, that would be $760.55 for 36 months. There's no shortcut here. The best way to do this, go back to the home screen. Okay, so let's do the bottom number first. $760.55 for 3 years or 36 months would be $27,379.80 is what you will wind up paying for that car. If I paid the $414.32 per month for 6 years or 72 months, that would be $29,831.04. How much more would it cost for 6 years than 3 years? I need to find the difference. So I'm going to do the 29,831 minus the 27,379, and that difference is $2,451.24. I think that that's key to know. Yes, it's going to cost me more interest if I finance for a longer time, but how much more interest am I actually going to pay? Okay. Number 5, a new 2019, so this is a little bit outdated, but a new 2019 Ram 1500 has a base price of $32,495 MSRP with a special financing of 1.9% for 60 months. What would be the payment on that loan? Okay, so let's go back to our TVM solver. 60 months, that's 5 years. Interest rate of 1.9% interest on a loan. We'll just assume we're going to finance the whole $32,495. What would my payments be? My payment would be $568.14. However, Dodge gives you an option. We'll give you an allowance of $2,500, but your interest rate goes up to 3.49. Which is the better deal, the lower interest or the smaller amount financed? Well, to make this adjustment, all I'm going to do is change my interest rate to 3.49%, and I'm going to reduce the amount financed by $2,500. My payment changes to $545.53. So I'm actually, in this case, better off paying the higher interest for the smaller amount. I've also seen where you're better off with the higher amount financed for the lower interest rate. You got to do the math when you're buying anything, including a vehicle. Let's look at some mortgage problems. My friends Pete and Kim, they bought their home for $250,000. The mortgage is a 30-year mortgage, as most of them are when you buy your first home. 4.2% interest. Over the years, interest rates, they go up, they go down. Currently, when they bought their house, it was at 4.2% interest. So 12 months for 30 years is 360 monthly payments they're going to pay on this mortgage. Interest rate is 4.2%, and they're financing $250,000. Their payment is $1,222.54. So any of you that are watching this video that have not owned your own home yet, that's your principal and interest payment. Depending on the situation of your loan, you might have principal and interest mortgage. Insurance, principal and interest insurance on your mortgage. You may be escrowing your taxes and your homeowner's insurance. So that's not the total payment or the cost of owning the home. That's the cost of the loan to buy their home. Now, it was 10 years ago that Kim and Pete bought their house. So it's been 10 years since they bought their home, and the interest rates have dropped. They've learned, as making of this video, mortgage rates are on their way up, but a couple years ago it had been 10 years, and the interest rates were down to 2.8% interest. They want to know, should they refinance? The first question is, how much do they owe now? What's the current balance on their account? How much do they currently owe? Well, if I make these these mortgage payments of $1,222 on a $250,000 mortgage at 4.2% interest, what's the current value? All I need to do is just say, I've been paying on that for 10 years. So I've made that payment 120 times. What's my current value of my mortgage? The future value after 10 years would be $198,281.05. That's their current amount. So if they're going to refinance, and we're ignoring fees that the mortgage company might put on there. So we're just going to assume that there's no cost to them to refinance. When they go to take out a new loan, they're going to borrow the $198,281.05 and notice that it's positive now. And we'll change everything else as we go. Their new interest rate would be 2.8%. Okay, if they get a new 30-year loan and they want to pay it off, what's their new payment? Their new payment would be $814.73. That's great. Their mortgage payment just dropped by $400 a month. However, they're restarting a whole 30-year loan. And so instead of taking them 30 years to pay off their home, it would take them 40. So suppose they say they don't like that option. They still want to pay their house off within the allotted 30 years. So what if we took a 20-year loan? So let's go back and simply change this financing of the current balance of $198,000 to 20 years or 240 months. What would their payment be? Their payment would be $1,079.92. So notice that their payment dropped about $150 a month, and they'll still pay their house off in the originally planned 30 years. They're also considering a new 15-year mortgage. Instead of a 20-year loan, could I pay off the house a little bit faster? So 12 months times 15 years, still at the 2.8% interest. Their payments would be $1,350.30. So in the third scenario, their payment goes up $130, but they also pay the house off 5 years earlier than they had planned on. So those of you that are going to be in finance, financial advisors, what would you advise Kim and Pete to do? That's a very wide open blanket question. And it really kind of depends on their life situation. I can come up with scenarios where each one of those might be the best option. So if you can just listen to me for a couple of minutes. If let's suppose that Kim and Pete, they've got a kid going to college now, and they need the $400 a month to make college payments, or they had other expenses come up and they need that $400 for those expenses, maybe restarting their mortgage isn't the worst idea. Or they want to drop their payment a little bit because they have a couple of expenses. They drop the payment a little bit. That $150, I'm looking at the second option here, part G. They're not lengthening the life of their loan, but they're putting a couple of bucks back in their pocket for current expenses. But they don't have a huge expense now. They could do that. Or maybe their financial situation is better than they were when they originally bought their house, and they can afford the extra $130 a month. So they go to a 15-year loan. Okay, so it kind of depends on what's best for their scenario, which is really my answer to most of these types of questions. Let's look at one last example here. This kind of refers back to something that we looked at earlier. An employee plans on working and contributing to her retirement account monthly for 44 years. Then she plans to live off of retirement savings for the next 25 years. I'm going to guess she's around 21, 25, early to mid 20s. She expects that her retirement account is going to earn 8% interest compounded monthly. So she's making the assumption of 8% over the next 69 years, or at least averaging 8% in her investment account. So the percent is 8%. She wants to take $5,000 monthly withdrawals from her account. How much should she contribute monthly during her working years? Now, the contribution comes last. First, like in the early example, how much money needs to be in that account? So if she's going to be retired for 25 years, 12 months a year, she's planning on being retired for 300 months. Her account needs to earn the 8% interest to make $5,000 withdrawals. Alpha solve on the present value. She would need her account to be worth $647,822.05. $1,246.62 when she retires. Now she's got 44 years. So 44 years times 12 months per year. She's got 528 months in order to save that up. So she wants the future value to be $647,822.61, and she's starting with nothing. What would her monthly contributions need to be? She would need to contribute $133 a month. Okay. So that's not bad. $133 a month gets her to that $647,000, $5,000 a month after that. I like to overthink some of these problems and kind of spin it around and say, okay, what if she says, $133 a month, that's really not that bad. I could up that to $150 a month. Okay. Well, what if she popped it up to $150 a month? What would the future value of that investment be? Notice that investment is now up to $728. And we say, okay, what if she retires with $728,000 into that account? How many, or what withdrawals could she take each month during the 300 months of her retirement? She could actually, for an additional $17 a month, increase her retirement monthly by $625 a month. Not a bad return. Okay, so there's a look at finance. I've got my specific examples. It's great to play around with your own situation. Take this forward with you as a consumer. And again, for those of you going into finance as a financial advisor. And again, I hope that this video was helpful. For those of you taking the course, you have a test coming up. And again, another reminder that in the test, there are a couple of problems where I'll want you to use the formula. Beyond that, I'm most happy if you can master the TVM solver. And that's true for those of you that are just watching this video, not in my class. To master the TVM solver is something that will serve you very, very well. So thank you for watching. If you got anything out of this, please remember to like or subscribe. And I hope to see you back in future videos. Thank you.